Everybody, welcome. I'm extremely pleased tonight to welcome you to the webinar. Linda Bazinet will be speaking with us tonight. My name is Anne Siskos. I am a program advisor at IHN. I have a background in education, and I'm also a recent graduate of IHN. And so Linda's webinar topic tonight is appetite and energy balance, the hormone connection. It's part of the continuing education course called Applied Endocrinology. It will be running this year in June, starting on June the 6th, and it runs for 7 Tuesdays. And if you're interested in learning more about the course, go to the IHN website. You can contact Colleen as well, Colleen at instituteofholisticnutrition.com. So the format for tonight, I was just speaking with Linda earlier. We think it's going to be about an hour of her talk, give or take.
Give or take.
Then, give or take, yeah. And 15 minutes or so of Q&A. At this point, just if you have some questions, we're going to leave them to the end. Please put them in the Q&A box as opposed to the chat. It just makes it a little easier for me to keep track of what the questions are. So now to introduce Linda, I think a lot of you know Linda already. She is a long-standing and beloved instructor at IHN. She has an extensive educational background herself, as well as an extensive teaching background. And she has a particular gift of making her students feel comfortable in what they're learning and confident as they go along the way. And especially for students who come into the program without a science background. So we are very grateful to have Linda on staff. Linda's background, she has a Bachelor of Science degree from the University of Toronto with a specialist in zoology and a major in biomedical science. She also has a master's degree from McMaster University in cell biology. Since 1988, Linda has been teaching at a variety of institutions, including Sheridan College and Seneca College. And she has done private tutoring and has taught a wide variety of courses. Listen to this list: biology, chemistry, inorganic chemistry, microbiology, histology, laboratory techniques, and environmental science. And that's just to name a few. I'm sure her bio isn't 100% complete here. And many of these courses have required extensive course development on her part. In other words, she's really smart and she knows her stuff. She has also taught a groups of mature students on site at Connaught Laboratories. And at IHN, she currently is on staff teaching biological chemistry, human anatomy and physiology, body metabolism, endocrinology, and advanced nutrition research. So Linda, we are so excited to have you here tonight to learn about the topic of appetite and energy balance through the hormonal lens. Everyone, please enjoy the evening, and I'll pass it over to you.
Okay, well, I'm going to start by sharing my screen. Let's make sure this works properly for us. And just go into slideshow mode. There. Okay, so we are talking tonight about hormones. Specifically, we're talking about hormones that affect appetite and energy balance. I know everybody's interested in weight. The hormones here are interesting because they're relatively new in terms of our understanding. Obviously, we've always had these hormones, but we didn't know about them. Both of these hormones, leptin and ghrelin, were not identified until the 1990s. We're going to talk about things other than leptin and ghrelin a little bit, but that's going to be our main focus tonight. Control of appetite and energy balance is complicated. And anybody who's ever tried to maintain an ideal weight knows that. These two recently discovered hormones, though, have key roles. Leptin seems to act as a satiety signal. In other words, to say that you are full. Ghrelin stimulates appetite. So they seem like they're opposites. If we look at this image, you can see on the left, it says before eating, ghrelin. Now, ghrelin's made mostly by cells in the stomach, and it's going to increase hunger. Leptin, you can see released by adipose tissue. On the right-hand side, it says after eating, leptin much higher, we're full. This is not as simple. Excuse me, it's not as simple as this looks. Because ghrelin is short-term. Leptin is long-term. So ghrelin, and I'll show you some charts later on as we go through the slides. Ghrelin varies up and down throughout the day. It actually goes up and down like before and after a meal. It's really cool. Leptin, on the other hand, is a longer-term signal. So this chart, although it's really nice and simple, is a little bit misleading. This is trying to show you a little bit, and we'll get into more later on, about the hypothalamus, because the appetite center is in the hypothalamus. And so all of these hormones that we'll look at are affecting neurons in the hypothalamus. The neuron that's being highlighted here is called an NPY AGRP neuron. NPY is neuropeptide Y. AGRP is agouti-related peptide. Believe it or not, it was first identified in agoutis. You don't need to remember that, but this is a neuron that is going to be involved in regulating appetite. Ghrelin, you can see, is going to upregulate that. So ghrelin, shown here from the stomach, upregulates that and increases appetite. Leptin, made mostly from adipose tissue, downregulates it and decreases appetite. So we're going to start with leptin. I love that picture of that poor little fat mouse. Isn't he cute? Poor thing. This actually is something that happened at random in a mouse colony. And these are mice that were being kept for scientific research. And they had some mice that were genetically fat, just naturally fat. It turns out that what's going on with the fat mouse, so you see the fat mouse on the right and then a normal mouse on the left. That fat mouse either doesn't make leptin. So there's two things that can go wrong. Either it doesn't make the hormone leptin, or it doesn't make the receptor for the hormone leptin. These mice were really fat, massive obesity. They have roughly 3 times the body weight and 5 times the fat mass of normal mice. They're excessively hungry, very, very hungry. Other things go wrong for them too. They have diabetes and cold intolerance, depressed immunity, and infertility. Obviously, these mice are not very healthy. These mice were studied for decades before they actually found the hormone. So leptin was finally discovered in 1994 through the studies of these mice. Leptin, they named it from the word from Greek, leptos, which means thin. This is the stuff I care about, not everybody cares about, but I love chemistry. It's a 146 amino acid protein that's secreted primarily by adipose tissue. Okay, you might care about that part. Interestingly, when they take those obese mice and they inject leptin into them, things happen. They dramatically reduce their food intake in just a few days. Remember, leptin's kind of a longer term signal. Within a month, they've lost half their weight, 50% reduction in body weight within a month. I'm beginning to think, where do I sign up? And we'll talk about that. Why do they lose weight? The weight loss from giving them leptin seems to come from a combination of factors. They are less hungry and they eat less. But they also have an increased metabolic rate. There's increased energy expenditure. One of the things is that leptin seems to raise body temperature. Leptin is a signal to your body that there's lots of nutrients and we can afford to have a higher body temperature. If we give leptin to mice who are normal, who don't have that genetic problem, to normal, healthy mice, if we give them leptin, they lose weight. And they lose a lot of adipose tissue, and they actually get an increase in lean mass. If we give leptin to mice before they get into puberty, they become thin, but they get into puberty faster. They reach reproductive maturity earlier than control mice. They begin cycling earlier. And this is one of the really interesting things about leptin, and actually one of the interesting things about hormones in general, is that they don't do just one thing. They do many things. And leptin affects not just appetite, but as you'll see here, fertility. And the logic behind this is leptin is a signal that we have lots of nutrients available. That means that it might be a good time to have babies. No, that was mice. What about people? Well, we make leptin too. And in our bodies, leptin is primarily secreted by adipose tissue. Little bits elsewhere. So small amounts of leptin secreted by many other tissues, including the stomach, the placenta, ovaries, skeletal muscle, mammary epithelial cells, so that's in the breast, bone marrow, the pituitary, and the liver. So lots of places throughout the body, but primarily adipose tissue. The amount of leptin expressed by adipocytes, now adipocyte is a fat cell, correlates well with the lipid content of the cells. In other words, the more fat inside the fat cell, the more leptin we make. So leptin increases as fat increases. So what does leptin do to us? Well, we're not all that different from mice. Leptin affects appetite. So in humans, leptin receptors are highly expressed in areas of the hypothalamus known to be important in regulating body weight. So the appetite center in the hypothalamus. There's lots of leptin receptors there. It turns out that leptin might also act on the brain stem. So while it is acting on the hypothalamus, it might be acting in other places in the brain as well. So leptin suppresses appetite and increases energy expenditure. Remember, leptin is a signal we have lots of nutrients. We don't have to eat as much, and we can afford to spend some energy. There are some humans who are like those fat mice. There's a very small group of humans who possess mutations for the leptin gene. And they, like those fat mice, are hungry all the time. So constant desire for food. And like those fat mice, we get severe obesity. So not many humans, most humans who are overweight don't have that problem, but some do. And the ones that do, you give them leptin, and we treat this successfully. So we decrease the desire for food, we decrease the obesity. That's just like giving the fat mice leptin, and they get to a normal body weight. When I say recombinant human leptin, that's human leptin that's been made in the lab. Usually they use bacteria to make it for them, but it's human leptin. Unfortunately, leptin is not going to be a miracle weight loss drug because that's not going to work in most people. Administering leptin is only going to cause weight loss in those individuals that have that mutation where they don't have leptin. And we'll get into that in just a few minutes. Human studies have demonstrated a strong positive correlation of serum leptin concentrations with percentage of body fat. I said that before. As fat goes up, leptin goes up. So it seems as the adipocytes, as the fat cells increase in size, as they accumulate more triglyceride, which is fat, they make more and more leptin. But here's the catch. You see the heading there, hyperleptinemia. Oh, that's a fancy word, isn't it? Hyperleptinemia. hyperleptinemia. That means high blood leptin. Blood concentrations of leptin are usually increased in obese humans. So you would expect that leptin should help us regulate our body weight. That if someone is overweight, when they have increased leptin, that should make them be less hungry and they should lose weight. But they don't. And we think what's going on is that they are insensitive to the leptin. So they don't have a leptin deficiency. That's why giving them leptin is not going to help them lose weight. They're not responding to the leptin they have. Here's something else that's interesting. Inflammation also contributes to leptin resistance. Oh dear. So inflammation is going to make it harder for you to respond to leptin. And it's kind of a double-sided coin here, because if you have elevated leptin, you can also have inflammation. Elevated leptin can cause low-grade inflammation. So inflammation can give you leptin resistance, and too much leptin can cause inflammation. That doesn't seem like a good situation. What you're going to find is that high levels of leptin are not healthy. Low levels of leptin are not healthy. What we need is the baby bear level. We need the perfect level of leptin. Elevated levels of leptin, hyperleptinemia, also increases the risk of type 2 diabetes. And in fact, it may also increase the risk of CVD. CVD is cardiovascular disease. There are a lot of other factors that can affect the secretion of leptin. Other hormones, glucocorticoids. Now, when I say glucocorticoids, that means cortisol. That's stress, right? Stress is going to make you make more cortisol. It's going to make you make more leptin. Estrogen actually also stimulates leptin secretion. But thyroid hormone, we think, decreases it. Now, that makes sense as well. Thyroid hormone, if we have elevated levels of thyroid hormone, usually people are thinner. They are hungry. Less leptin, more hunger. Insulin has an effect as well, and insulin and leptin unfortunately seem to be linked. Insulin increases leptin secretion, probably through stimulation of glucose metabolism. So if we have more leptin, more insulin, we're going to get more leptin. Insulin increases when we have lots of nutrients, particularly glucose. Interestingly, if we have somebody follow a high-fat diet for as little as 24 hours, leptin levels decrease. Now, that high-fat diet is going to lower insulin levels. So the mechanism is probably due to the effect of high-fat diet on glucose metabolism. So we're going to change insulin. We're going to change glucagon levels as well. But if we lower leptin levels, then we're going to get hungrier. Oh, and so we think that the lowered leptin levels that we have with the high-fat diet might actually promote weight gain and obesity when we follow that type of diet. So we would like to restore leptin sensitivity. We would like to be able to respond properly to this hormone, because being insensitive to leptin is a contributor to weight gain. First off, why does it happen? We're not sure. I think there may be a couple of different things going on. We say that leptin resistance might be because the receptor is not responding properly. Now, sometimes when the receptor is not responding, because the receptor itself has changed. And sometimes the receptor is not responding because it's not sitting right in the membrane. The other thing that might be happening is that there is leptin, but it's not getting to the hypothalamus. We think there could be a decreased ability of leptin to cross that blood-brain barrier. So you can have all the leptin you want in the blood. If it's not getting to the hypothalamus, it's not going to have an effect. So researchers are studying a number of leptin sensitizers to try to restore that sensitivity. Now, notice I say they're investigating. That means we don't have it yet. We don't have that ability to restore it easily. So let's think if we can restore it the hard way, which means changing our lifestyle. Insulin insensitivity leads to leptin insensitivity. And so when we have people who are insensitive to insulin, they're more likely to become insensitive to leptin. And so anything that restores the sensitivity to insulin usually is also going to restore sensitivity to leptin. There's my first recommendation. I said it wasn't easy. It's effort, exercise. Exercise will help restore sensitivity to leptin. Here's another one, reducing sugar intake. Reducing sugar intake, particularly fructose. Yeah, fructose, we have more fructose intake than we have ever had historically because of, in particular, high fructose corn syrup. Fructose leads to leptin sensitivity. We think it might block the receptors. And reducing triglycerides. And that's reducing triglyceride levels in your blood because triglyceride seems to block the transport of leptin into the brain. So those are not easy things to do necessarily, but they are things that are going to make a difference. So simple picture here. Again, you can see on the left-hand side, well, actually look at the bottom, adipose tissue. We follow up the arrow to the left, weight loss. We lose weight. If we lose weight, well, less fat, less leptin. Up at the top, the hypothalamus in the pink box, less leptin, we're going to eat more food. Our body temperature is going to drop. Our energy expenditure also drops as less food available. Also decreases our reproductive function. But the parasympathetic activity goes up. On the right-hand side, when we gain weight and our leptin levels rise, our food intake will decrease, but our energy expenditure can increase. Our sympathetic activity actually will increase, and it's not listed there, but the reproductive function can also increase. And so let's talk about reproduction. So we said leptin affects appetite, but leptin also affects reproduction. And as I say, leptin is a signal we have loss of nutrients. That's a good time to have babies. And we know that leptin concentrations are low in people with low body fat. You also know people with low body fat sometimes have trouble with fertility. Leptin appears to be a significant regulator of reproduction function. And in fact, leptin is able to enhance secretion of GnRH, is gonadotropin releasing hormone. It comes from the hypothalamus and it stimulates release of what we call LH and FSH. LH is luteinizing hormone. FSH is follicle stimulating hormone. And so those two hormones regulate reproductive function, both in men and in women. So some people who have problems with leptin receptor gene. So these are people like those genetically fat mice who genetically don't make or don't respond to leptin. Not only those people obese, they don't go through puberty. And so leptin here is clearly associated with fertility, or in fact, here, not being able to respond to it and not having leptin stimulating GnRH, we don't get puberty. If we give leptin to mice, remember they said they reached reproductive maturity at an earlier age. One of the interesting things I read about was that injecting leptin is being used possibly to help women with low body fat ovulate. Women with low body fat have trouble with fertility, and leptin injection looks like it's going to be possibly able to help with that ovulation. On the other hand, so low leptin, you're not fertile. High leptin, problems too. So again, you want that in-between level of leptin, the normal level of leptin. High concentrations of leptin adversely affects fertility. I was reading some interesting articles on this. So excess leptin. So we're looking again at high, above normal levels of leptin, which we'll see in leptin resistance. This may contribute to reduced reproductive function in men, in obese men. High concentration of leptin associated with decreased testosterone, abnormal sperm morphology. In women with unexplained fertility, leptin levels are higher. High leptin in the ovary actually can suppress estradiol production, that's your main estrogen, and predispose to anovulation, that means not ovulating. So high concentration of leptin can interfere with fertility for both men and women. Low concentrations of leptin also interfere with fertility. So again, we need to have the medium level of leptin. So leptin affects appetite. It affects reproduction, but it affects more things too. In addition to its effects on appetite, energy balance, and reproduction, leptin seems to have broad effects on inflammation. Leptin is not only classified as a hormone, it's classified as a cytokine, which is a signaling molecule in immunity, and it's pro-inflammatory. So high levels of leptin are inflammatory. And we think that contributes to chronic inflammation in obesity. Leptin affects hematopoiesis. Hematopoiesis is making blood cells. And angiogenesis is making new blood vessels. And so while the angiogenesis generally seems like a good thing, making new blood vessels for new blood circulation, the hematopoiesis, if we have leptin levels that are abnormally elevated, you may end up with too many of some types of blood cells. Blood pressure, leptin increases blood pressure. Leptin affects bone mineral density. And I didn't say up or down because I was reading, and in some cases it's up, in some cases it's down. It depends on the particular situation. It depends on the body part too. High leptin reduces vasodilation. So it means your blood vessels are going to be more narrow. They're not going to be dilated. They're going to be more narrow. And it may affect blood clotting. And high leptin seems to increase risk of heart attack and stroke. So we're looking at these elevated leptin levels in people with hyperleptinemia. And there's a whole host of health concerns that come along with it. You can see here, there's leptin, and you can see it says, if you go from the upper left corner, increases blood pressure, actually affects thyroid hormones. It decreases some of the insulin secretion a little bit, increases heart rate, affects bone mass, is involved in regulating fertility, affects appetite, activates some of the immune cells. So lots and lots of different effects of leptin. Immunity, the effect of immunity is pretty complicated. Low levels of leptin decreases immunity. It's associated in increased disease susceptibility. So if we have leptin levels that are below normal, we're more at risk for getting sick. High levels of leptin associated with increased risk of autoimmunity. And then look at some specifics. Leptin inhibits the NK cells. NK cells are natural killer cells. That's part of your normal immunity. NK cells will go after virus-infected cells, cancer cells, for example. Leptin stimulates monocytes. Now, monocytes become macrophages. Macrophages like to eat up things. And actually, they can be very helpful for eating bacteria and dead cells and so on. We're going to regulate the adaptive immunity. So it actually activates T cell and B cell proliferation. And interesting, you might remember we said leptin was made by the placenta. It might be involved in some of the changes in immunity that occur during pregnancy. There's some immune tolerance, for example, that happens during pregnancy. And this is a detailed diagram showing leptin in the center and looking at a wide range of effects on immunity. So while we started off by saying that leptin is your satiety signal and says that you're full, you can see from everything we've talked about here, it's much more than that. I'm not going to go through each one of those. We kind of summarized it in the slide before. So that's leptin. Let's talk about ghrelin. Ghrelin always makes me say grumble because ghrelin is a hunger hormone. Ghrelin makes you hungry. It's smaller than leptin. It's a 28 amino acid peptide. And it's made mostly by epithelial cells lining the fundus of the stomach. That's the upper portion of the stomach. The interesting thing about ghrelin, and again, there's lots of interesting things about ghrelin, is that it promotes growth hormone secretion. So the prefix GHRE here actually means growth. And so ghrelin is tied to growth hormone. And in fact, historically, when ghrelin was being discovered, we knew that there was something binding to a receptor that stimulated growth hormone secretion. We didn't know what it was, but we knew that whenever this thing bound to this receptor, we got growth hormone. So you see that cells within the anterior pituitary bear a receptor that, when activated, potently stimulates secretion of growth hormone. And so they called it this fancy term, growth hormone secretagogue receptor. Basically, it means that when something binds to this receptor, we get growth hormone. The natural ligand, in other words, the molecule that naturally binds to this receptor, was announced in 1999 as ghrelin. So we've only really known what ghrelin is for just over 2 decades. Every year when I give these talks, when I do endocrinology and I lecture on leptin and ghrelin, I have to go away and look at the literature and find out what we found out last year, because every year we're learning more things about these hormones. So the ghrelin receptors are present on what are called somatotropes. Those are the cells in the pituitary that make growth hormone. Actually, growth hormone is also known as somatotropin. But we have ghrelin receptors elsewhere too. So we have ghrelin receptors. So ghrelin is made in the stomach. There are receptors for it in the pituitary. But there are also receptors in the hypothalamus. Oh, appetite center, right? Also receptors in the heart and adipose tissue. What does ghrelin do? Well, the first thing we say, it potently stimulates secretion of growth hormone. I'm thinking I should be hungry to get more growth hormone. In both rodents and humans, and we're not that different from mice, ghrelin increases hunger. Ghrelin increases hunger. And it does so by acting on the hypothalamus feeding centers, and that's the NPY neurons, the neuropeptide-wide neurons, same neurons that were being affected by leptin. This sounds like a cruel study. Humans injected with ghrelin report sensations of intense hunger. Okay, I'm not going to sign up for that one. Ghrelin appears to suppress fat utilization in adipose tissue. Oh, but I want to use my fat. It heightens the appeal of high-calorie foods. So that would be calorie-dense foods, fatty foods. Ghrelin levels are elevated in stress. And your first thought there is, well, if ghrelin is elevated during stress and ghrelin makes me hungry and I'm going to eat more, maybe I don't want to eat more, so maybe I should try not to be stressed. Okay, that makes sense. But it looks like ghrelin really helps us cope with this. So being hungry during stress apparently is beneficial for us. This statement, this is ghrelin knockout mice. Now that sounds like a weird thing. This is something they do in research where they develop mice that don't have a particular ability. And so when we say ghrelin knockout mouse, that means a mouse that is not able to make ghrelin. So they've manipulated this mouse so we can't make ghrelin. And those mice are more anxious. So apparently ghrelin helps us cope with stress. It seems to enhance our ability to cope with stress by stimulating the HPA axis, that is the hypothalamus pituitary adrenal axis. So yeah, ghrelin makes you hungry, but it also helps you cope with stress. It also stimulates reward And pleasure centers. By the way, that's going to be in the hypothalamus too. Ghrelin stimulates gastric emptying. And it has positive effects on cardiovascular function. It increases cardiac output. Now, we're not sure that that's due to ghrelin itself, because ghrelin stimulates growth hormone, GH is growth hormone. Ghrelin stimulates growth hormone secretion, and growth hormone could do that. So it may be indirect through growth hormone. Ghrelin may enhance learning and memory. It actually affects the hippocampus. So I'm thinking maybe I shouldn't be eating before I study. Maybe if I study when I'm hungry, I'm going to remember better. I haven't seen a study that looks at that. I'd love to see that. I'd love to see a study that looks at that. And maybe if I go digging, I'll find one eventually, because it seems like an interesting model. I don't know if I like that model, but it's an interesting one. Oh, what? Fertility too? Yeah. Mice whose mothers had low ghrelin levels were less fertile. Ghrelin is also responsible for direct activation of dopamine secreting cells in the brain. And what's interesting about that is that Parkinson's is caused by degeneration of dopamine neurons. And in fact, it's possible that ghrelin could be used to boost resistance to Parkinson's or slow development of Parkinson's disease. And so there's research going on looking at whether or not ghrelin is beneficial for people with Parkinson's. Variations in ghrelin secretion. Ghrelin secretion varies up and down throughout the day. It is affected by circadian rhythm. So unlike leptin, which is kind of a longer term signal, ghrelin goes up and down throughout the day. Ghrelin levels increase before meals. When you're approaching what your normal meal time is, you're going to feel hungry. Ghrelin levels decrease after meals. And it's not just the act of eating that causes the decrease. You can see it says affected by circadian rhythm. If you skip a meal, which I don't advise, but if you skip a meal, you're going to get hungry as that mealtime approaches. And as it passes, your hunger is probably going to decrease because ghrelin is going to drop a little bit anyway because of the circadian rhythm. But overall plasma ghrelin concentrations do increase during fasting. And so this is fairly straightforward. You can see that if you start on the left-hand side, you see hunger stimulates the release of ghrelin from the stomach. Ghrelin then travels in the blood to the hypothalamus. It's going to act on the hypothalamus to stimulate appetite. When you eat, it's going to cause blood levels of ghrelin to decrease. Nice and simple. This is cool. You can see the up-down that we get with this. And so you can see here, ghrelin, there's breakfast. Ghrelin levels rise before breakfast, and then they drop. Here's lunch. They rise before lunch, and then they drop. Well, they don't seem to be as low in the afternoon. I might want to do some snacking. And then they rise before dinner, and then they drop. Although it's kind of cool to see this rise overnight. Now, hopefully you're not going to be eating because I expect that you're going to be sleeping, but ghrelin levels do rise a little bit overnight. And one of the interesting things is that growth hormone secretion often increases overnight as well. And so that's possibly tied to some of the ghrelin. We keep looking for nice, easy treatments for obesity. And so the possibility was raised that maybe we could have a vaccine that would prevent obesity. So ghrelin is a prominent target for development of anti-obesity treatments. If we immunize rats against ghrelin, we get decreased weight gain and adiposity, so less fat, relative to control rats. Although both groups actually consumed an equivalent amount of foods, we're actually changing metabolic rate here as well. So it raises the possibility of a vaccine against obesity. But I read about that many years ago, and I haven't seen significant progress here. So I have a feeling this one's not going to pan out. we can have abnormal levels of ghrelin. Ghrelin concentrations are reduced in obese humans compared to lean control substances. Wait a minute. People who are overweight have less ghrelin? Okay, well, they should have less ghrelin because they've eaten a lot. But then why are they overweight? Why are they still hungry? So abnormal ghrelin levels might not actually be the cause of obesity, because ghrelin should be lower in these people, and it is. But we think they might be more sensitive to that ghrelin. After dieting, ghrelin levels rise. And that might be a factor in weight gain after dieting. Many people after a diet start gaining weight and go back to where they started. Now, here's something that's interesting. Ketogenic diets actually affect that. Ketogenic diets suppress the increase in ghrelin that's normally absorbed after weight loss. So normally after weight loss, there's an increase in ghrelin and you start gaining weight. On a ketogenic diet, that doesn't seem to happen. Interestingly, taking in, so exogenous ketones, taking in ketones, so not being on a ketogenic diet, but just taking a ketone supplement also has an appetite suppressant effect. Now, the effect of ketogenic diets on satiety, hormones, other ones, is not clear. And so it does seem to have an effect on ghrelin, but we're not sure what the effect is on. And you'll see, I mentioned these three hormones, the short sections, after we finish talking about ghrelin. We're talking about CCK, something called glucagon-like peptide 1 or GLP-1, and peptide YY. Those are all satiety hormones. And we're not sure what the ketogenic diets do for that, but we know that it has an effect on ghrelin. Patients with anorexia nervosa have higher than normal plasma ghrelin levels. They should be hungry, but they may not be sensitive to ghrelin. They may be insensitive to ghrelin. Now, anorexia is a very complex condition, and I don't think that the underlying cause is the same for everyone, but this is one of the things that can be going on. If these individuals do manage to gain weight, the ghrelin levels are going to decrease and ghrelin sensitivity is restored. Other things that affect ghrelin, short sleep duration. So not sleeping enough hours, associated with increased ghrelin. So when you don't sleep long enough, you tend to be hungrier. And I remember nights, particularly when my son was young, when I would only get a couple hours sleep. And I remember I would eat my way through the whole next day. And so I can relate to this one. Short sleep duration, not sleeping enough hours, is also associated with reduced leptin and increased BMI. And so one of the things that people need to address when they're trying to get to an ideal body weight is sleep. Sleeping the right number of hours is an important component to this. Now, this is kind of like an aside. This is an interesting little story. This is something called Prader-Willi syndrome. This is a condition that some children are born with. I want to say it's genetic, except it's not inherited. And so it's not that it is going to be passed down from one generation to another. It arises randomly. So it is a genetic error that occurs, but it's not going to be inherited per se. These children, as infants, have poor muscle tone. They have trouble sucking. They actually have feeding difficulties and failure to thrive. Now, failure to thrive is a term we use with babies. It means they don't gain weight properly. They don't go through the proper developmental milestones. The boys here may also have undescended testicles. Now, initially, these children, the babies, don't feed well just because that's really because of the poor muscle tone. But what we're going to get to is that they're going to have high ghrelin and they're going to be exceptionally hungry. So later, other symptoms appear: short stature, poor motor skills, weight gain, underdeveloped sex organs, mild intellectual and learning disabilities. I was reading about this one before I came into the lecture tonight, and is complex. It has to do with one of the chromosomes, and a portion may be missing. And so the different thing, and in fact, it doesn't always seem to be the same thing that's happening from one individual to another. But not only is ghrelin going to be affected, but growth hormone typically is affected, and ghrelin and growth hormone often go together. But you can see that short stature affected by growth hormone. Also, we need growth hormone for proper fertility. And so that's going to be probably affecting some of the underdeveloped sex organs. So subjects develop extreme obesity associated with uncontrollable and voracious appetite. These subjects have exceptionally high plasma ghrelin levels, and that's why we're talking about it. They have exceptionally high plasma ghrelin levels in comparison to patients who are similarly obese due to other causes. I've read case studies of these. With these children, they are hungry all the time. And if they don't get food, they will throw huge temper tantrums, and they will eat things that aren't food because they're starving. You have to lock the cupboards. And often individuals with this condition end up having to be in a group home, and they have to be really watched quite carefully. I know behavior modification can be helpful in treating some of these individuals. Treatment includes growth hormone, exercise, dietary supervision, that's key, sex hormones, behavior therapy. So the abnormality is on chromosome number 15, as it's kind of complex, but it's chromosome 15 that's affected. This happens in 1 in 10,000 to 1 in 25,000 individuals. And so there's a picture of a little guy with Prader-Willi, which is kind of a sad looking story. I was reading life expectancy. Typically, these individuals live into their 30s, although some people live into their 60s with this. So you can have a relatively long life with this condition, but there's going to be extensive treatment needed. And ghrelin is clearly one of the key things going on with these. Okay, a little bit more cheerful. You see ghrelin here from the stomach affecting, so many things. Behavior, mood, hypothalamus, appetite, growth hormone, heart, insulin secretion, and affecting a little bit of activity through the GI tract. There we go. This is a nice one. You can see ghrelin is affecting energy expenditure, appetite, and then cell proliferation and differentiation, heart, influences on gonadal axis. So that would be fertility, regulating insulin secretion, glucose metabolism, gastric secretion, so much. And there's so much more we're going to learn about ghrelin as the years go by. So we've only known about it for just over 20 years. CCK, cholecystokinin. This is a hormone that I talk about in anatomy physiology when we talk about digestion, because it's a very key hormone that regulates digestion. CCK is released by what's called the eye cells in the mucosa of the duodenum. It is very important in regulating digestion. It stimulates the release of enzymes from the pancreas. It also stimulates the expulsion of stored bile. So you get this spurt of bile, and also secretion from the small intestine. The small intestine actually makes quite a few enzymes, and their release is stimulated by CCK. The small intestine secretion is done by little sections called the crypts of Lieberkühn. There should be 2 little dots over that U. I didn't get the special symbol in there. CCK stimulates digestion in the small intestine, but it slows down the stomach. It suppresses gastric emptying. CCK is released when we have food entering in the small intestine, particularly if it's high fat. Fat takes a while to digest, and so we want to slow down the stomach so we don't get more stuff into the small intestine until we're ready to deal with it. But it actually stimulates peristalsis in the small intestine, so it's going to encourage the activity in the small intestine. So slow down the stomach, encourage the small intestine. And I call that an anticipatory rise in insulin. We're going to encourage insulin release, because if we have CCK, there are going to be nutrients. So we're going to need insulin to get them into the cell. But CCK also affects hunger. It triggers satiety in the brain, but this is a short-term effect. So this isn't a long-term effect. This is a short-term effect. It actually might work by enhancing transport of insulin to the blood-brain barrier because insulin actually makes you feel full. And so CCK may well be tied in with insulin. Individuals with severe obesity may actually be less sensitive to CCK. And I came across this one and I was trying to figure out why, and I can't figure out why. CCK in the brain may play a role in anxiety and panic disorders. That elevated levels of CCK in the brain will increase anxiety. I could not find an explanation anywhere as to how this could be connected with the other roles of CCK. And so it might not be. It might be a separate role of CCK. And I'm going to keep looking for it because I want to understand that one. And I spent a while researching, trying to find further explanation of that. And I came up empty, to be honest. CCK agonist. Now, what is an agonist? Basically, a CCK agonist would be an artificial molecule or a medication that would have the same type of effect as CCK. So it would bind to the same receptors that CCK has. In other words, we're trying to find a supplemental medication that could act the way CCK does in the body. And these are being investigated as possible treatments for obesity because CCK makes you feel full. But when I was reading about this, they were running into problems with the trials because CCK also increases that intestinal motility in the peristalsis in the small intestine. So when they try using those CCK agonists, you end up people with cramping and diarrhea. And so that makes this less likely as a possible obesity treatment. Cholesterol affects the binding of CCK to its receptor. So, and this is cholesterol in the cell, cholesterol in the membrane, affecting how CCK works. And so if we have elevated levels of cholesterol, we're going to alter the ability of CCK to do its job. We've talked about insulin a few times. I don't have a lot to say about it here, but it does have an effect on appetite. I always say insulin is a hormone of abundance. We release insulin when we have lots of glucose, although insulin is also released when we have protein. Stimulation of brain insulin receptors is associated with reduced appetite and weight loss. And in fact, the studies are done with intranasal administration of insulin. And the reason they do intranasal is because that actually bypasses the blood-brain barrier. But they do that and you get decreased appetite. So insulin definitely decreases appetite. But we think that we can have insulin resistance in the brain too. We have insulin resistance throughout the body. We have insulin resistance in the brain, and that can happen due to decreased transport of insulin into the brain. And so again, having elevated insulin is not going to decrease appetite unless it gets into the hypothalamus where it's supposed to do its job. This is one you may never have heard of. Glucagon-like peptide 1 or GLP-1. Glucagon is released from the pancreas. I always say is insulin's evil twin. Glucagon is released often when blood glucose is low. So glucagon-like peptide is similar to glucagon, but it's called GLP-1. And it's actually made by the small intestine and the pancreas too, actually, and central nervous system, but mostly in the small intestine by cells that are called L cells. It's going to encourage the release of insulin and decreases glucagon release, which actually slows down the release of glucagon, increases the release of insulin. It's going to slow down the stomach and acts on the hypothalamus, again, to increase feelings of fullness. GLP-1 agonists are actually used as medications. So GLP-1, again, the agonist means it acts like this one. It's going to bind to the same receptors, have the same effect. And there are medications that are these that are used in the treatment of type 2 diabetes and obesity. It makes sense that these are used in type 2 diabetes because, look, it encourages insulin release. So there are diabetes medications that stimulate the pancreas to release more insulin. GLP-1 agonists are some of those medications. Peptide, why? It's related to something called pancreatic polypeptide, which we haven't talked about, but is another substance made by the pancreas. It's released by cells in the ileum and the colon in response to feeding. So another peptide released when we eat. It acts on the NPY receptors in the hypothalamus. And it decreases appetite. It slows down the stomach. It inhibits gastric mobility and gastric emptying. Obese people make less peptide YY. And so again, this is another one of those substances that we're looking at as a possible treatment for obesity. It's a potential weight loss drug. But it's potential. We don't have it yet. So we keep talking about the hypothalamus. I thought we kind of focus in on the hypothalamus for just a couple of minutes. We're getting close to the end of this talk. But we know the hypothalamus is our control center for hunger, for satiety, so hunger and fullness. Some peripheral proteins and peptides directly interact with neurons in the hypothalamus. We've been talking about a bunch of them. We keep saying, okay, insulin's going to act on the hypothalamus. Ghrelin's going to act on the hypothalamus. Leptin's going to act on the hypothalamus, and so on. So a lot of these come into the hypothalamus and act on it. Well, what are they doing? They're acting on some neurons that secrete particular molecules. So there are two classes of neurons that we're talking about here. The one that I've mentioned so far is NPY and AGRP. So this is one type of neuron. It secretes neuropeptide Y, which is the most abundant neuropeptide in the brain, and AGRP, which is a Agouti-related peptide first identified in agouti. But the other neurons, so that's one class. The other one secretes something called POMC and CART. CRT is, well, we'll see what they stand for when I get the diagram up. It's long, complicated names. But there we go. NPY and AGRP, those stimulate food intake and weight gain. So NPY and AGRP are going to act to make us hungry and gain weight. POMC and CRT, so the other neurons, are going to inhibit feeding and promote weight loss. And what I find really interesting is some Labrador retrievers have a mutation in POMC. So 25% of labs have a mutation in POMC. Now, I've had 2 Labrador retrievers. I don't right now. Right now, I've got a golden doodle puppy who is lots of fun. I'm totally different from my labs. I can't believe this dog's not hungry all the time. I'm used to Labrador retrievers. Labs, I like to say the only time they're not hungry is when they're eating. Well, it turns out that many labs actually have a genetic reason for being hungry. If they don't have proper POMC, that's supposed to inhibit feeding. Well, they don't have that, so they're always hungry. So this diagram is illustrating some of what's going on here. So you can see that we've got the two here. This is your AGRP NPY neuron. And this is the POMC CART. And I don't know if you can read down the bottom. POMC is pro-opiomelanocortin. And CART is cocaine and amphetamine related transcript. That's because this particular molecule has similar effects as cocaine and amphetamines do on the brain, which is interesting. And cocaine and amphetamines actually encourage the secretion of that one. AGRP, as I said, was a Agouti-related protein or peptide and NPY is neuropeptide Y. Then you can see here is ghrelin. Going to come into the brain, and can you see this upregulate? Ghrelin is going to upregulate the AGRP NPY neurons. That's going to increase food intake. Actually acts on another neuron to do that, but it's going to increase food intake. POMC and CART, that's going to decrease food intake. And you'll notice that insulin, leptin, and CCK all stimulate the POMC CART neurons and actually inhibit the AGRP and NPY neurons. And so there's a lot going on here, but it's all really going to be happening ultimately in that hypothalamus. So we've talked about a lot of different hormones that affect appetite and energy balance. These are hormones you might not have been familiar with. I think you're going to remember the leptin and the ghrelin best. Leptin, long-term signal, satiety signal. We have lots of nutrients. We don't need to eat that much. We can afford to do things like reproduce. Ghrelin, short-term hunger signal, also potently stimulates growth hormone. All of these work eventually through the hypothalamus. So I hope that you enjoyed that kind of walk through some of the hormones that affect appetite and energy balance. There's actually quite a few of them. So it's very interesting, and we're going to learn more. And I'm looking forward to doing this lecture again in the future when I've learned more. So that's pretty much it. There you are, Anne. Good. So much stuff.
Wow, Linda, you really have highlighted your depth and breadth of knowledge. Thank you so much. I know it sparked a few questions in me. So just a reminder to all of you attendees, if you have some questions, could you put them in the Q&A box below? Miriam, I did pick up the one that you put in the chat already. So let's start with the first one. And yes, okay, from Diana. Linda, does intermittent fasting affect leptin and ghrelin?
That's a good question. And I haven't actually specifically looked at that. The thing is, I don't think it's going to affect leptin. I would be surprised if it affects leptin, but I wouldn't be at all surprised if it affects ghrelin, because I know that intermittent fasting affects growth hormone. Right? Intermittent fasting is one of the ways we have to increase growth hormone. And so I suspect that it probably is going to have an effect on ghrelin. But I'm not sure whether or not that's going to be translated to a big effect on how hungry we are. So what I'm going to do, and I've done this in the past, what I often suggest, I think when people register for the webinar, you get their emails, right? And I think you get all the information. So what I've done in the past, when people ask me questions that I haven't actually researched that much, or I don't have a definite answer, is I will in the next few days do some research. I will send you a summary of what I can find on that, and then you can send that out to the panel. Does that work for you?
Yeah, sure. I think I can't say for sure if that's a procedure, but I did mark that down, and I'll check with that.
So I did that 2 years ago. I know I did it 2 years ago, so I'm thinking they can probably do it again.
Okay.
Because sometimes I know, and that's what I said to my husband's son before this. I said, I don't know if I can answer all the questions. There's so much here. And I hadn't looked into it because I think that intermittent fasting might, but I think specifically it's probably going to be ghrelin as opposed to leptin, is my guess. Yeah.
Okay. And similar, Shreya is asking what's happening during fasting with ghrelin and leptin. And I mean, intermittent fasting is that regular non-eating window, but you know, especially coming off of Ramadan and so on, there's other types of fasting.
We do know that fasting is going to cause increase in ghrelin levels. Mm-hmm. But again, leptin is longer term. Leptin is going to be more to do with how much fat you have. And so if the fasting does change your body, does change your amount of adipose, like the fat in the adipocytes, then you might get a change in leptin. But chances are, if you're maintaining your body weight, but you're fasting, it's going to be ghrelin that's affected, not leptin, because ghrelin is much more short term. And so I know that fasting does increase ghrelin.
Great, thanks. Okay, very timely question from Miriam. Please explain about Ozempic, this new drug that all the Americans are buying, all the Canadians supply.
You're going to ask me to remember how Ozempic works. It's interesting because I know that it's been recommended for someone I know that it should take it, because Ozempic is normally supposed to be used for diabetes. I know that it's used as weight loss, but it's meant to be for diabetes. And I'm just trying to very quickly see, because I actually haven't gone away and researched Ozempic, which is an interesting one, but I might be able to get it very, very quick.
While you're looking that up, I just have a little commentary. About 10 years ago, I went with my husband to a fundraiser for Willie Prater syndrome. And
really?
Indeed, it is, we saw a very heartfelt video, and I met quite a few parents with children with Willie Prater, and it is quite heartbreaking. But the fundraiser was for research. So I think, there's more being learned about it each year that goes by.
I've got a quick answer for you on Ozempic. It is a GLP-1 receptor agonist. So we were talking about the GLP-1 receptor agonists, and it's that's what Ozempic is. So it interferes with, that was the glucagon-like peptide. That was the one that increases insulin secretion. So Ozempic is going to increase insulin secretion and lowers blood glucose. So it stimulates insulin secretion and lowers blood glucose. And so it gets your body to use more of the glucose. It's going to lower blood glucose and affect it that way. So that's what it does. It actually, so we were talking about the glucagon-like peptide agonist. That's what it is.
Yeah, makes sense.
Yeah. So it lowers fasting and postprandial. So after eating blood glucose. Semaglutide, that's what it is. I remember what the actual name of the molecule was. Yeah.
I have a question. So I love how you explain the hormones being we need to kind of have them in the Goldilocks zone. And that's not different from any of the other hormones that we talk about. Mm-hmm. I don't think in the program. But is it common for people to have their leptin and ghrelin levels checked? Or
no.
It's only if you have this hyper...
It's very rare to have them checked. Yeah.
Yeah.
Yeah. In fact, somebody who's obese go to the doctor, they're not going to look at the leptin. It'd be a very rare thing to do. And so most of the time, these things are looked at in research studies. I don't think it's reached the clinical stage at this point. Remember, we've only known about these things for just over 20 years. And medicine moves slow from that standpoint.
Yeah. Okay, everybody, do we have any more questions out there? I'm not seeing any more in the queue.
That's just because I inundated you with information.
Yeah, that whole idea, the more you know, the less you know.
Oh, I know. Well, that's every time I read about this, I think, oh my God, there's more. I didn't know it did that. What amazes me with leptin, I think of it as being, okay, it's you're full, but wait a minute, it's not just you're full, it's you can reproduce. Oh, wait a minute, too much of it, now you have all these other health issues. The effects of leptin on immunity. I was going down the rabbit hole with that one, because you start reading and it gets really fascinating. Because too little leptin, you get sick. Too much leptin, you get autoimmunity.
Yeah, it's super complicated.
It is, but that's what makes it interesting. That's what I love about, even when we get into the endocrinology course, all of these hormones do more than you think. And we will describe them and say, well, it does this. And you look at it, yeah, but it does this, this, and this. And so often the effects seem to be on immunity. The other effects seem to be on immunity.
Right. Well, thank you everybody for attending this wonderful lecture. If you are interested in the applied endocrinology course, it does start on June the 6th, and you can reach Colleen at instituteofholisticnutrition.com, or go on the website and just have a look at the topics there. My ghrelin levels have been increasing a little bit. It might be time, and also
That means your memory's good. That means you've been doing this, right? Because it leptin increases memory.
Oh, okay. So I suppose that's good.
Yeah. So you're.
So, okay. So, we got through a lecture without a Star Wars reference. So if you want Star Trek.
I don't do Star Wars, Star Trek.
You might get a Star Trek reference if you sign up for the course. So thank you everybody for attending. And Linda, thank you so much for sharing your time and expertise.
You're welcome.
And I hope to see some of you in the future course.
It'll be fun.